Alright, so in this time problem solving walkthrough, we are going to be solving a question problem from the 2009 AMC 10A, number 15. So let's get started. So, the figures F1, F2, F3, and F4 are the first in a sequence of figures. Okay, so in this problem, for n, okay, so let's finish reading it. For n, it's greater than or equal to 3, Fn is constructed by, and n is basically like over here, n is equal to 4, over here, n is equal to 3, over here it's 2, over here it's 1. Is constructed from Fn minus 1, so in this case it's constructed from F3. F4 is constructed from F3 by surrounding F3 with a square and placing one more diamond on each side to the new square. So we're just adding squares on each side. One more than it, of course. F3 has 13 diamonds. How many are there in F20? Okay. So for this problem, I want you to get the base down because this is a pretty challenging problem. So I just want to get the base down and try one of these test cases and see what you find. There are multiple solutions to this problem. Remember that. Alright. So hopefully you've come up with some sort of solution. We're going to start pretty basic by constructing F3. But we're gonna construct F3 in a different way. We're first going to construct F2. Just the diamonds. Now we have F2. This is right here is F2. Now let's construct F3. So we add a diamond over here. We add a diamond over here. We add a diamond over here, over here, over here, over here, over here, and over here. And believe it or not, we've successfully constructed F3. Now this diamond should be in the middle more. And we just join these diamonds in the center to form some diagonals. And then we can just connect these by just squaring it off. Now notice how F3 is just I want you to count the diamonds on each side. So like over here we have 3 diamonds, over here we have 3 diamonds. Now I want you to count F2, and we need to label this F2. Square it off. There we go. Now do the same thing for F2 and see what you find. Okay, so you might have noticed you have 2 and a 2. Now, notice how F3 forms a 3 by 3 square. We can now conclude that Fn forms an n squared figure, right? Or n times n, if you want to call it that way. Now, Fn is constructed from Fn minus 1. In this case, Fn minus 1 is F3 minus 1, which is F2. Now we take F2. Fn minus 1 is, what's that Fn minus 1? I want you to just finish this part off and do the problem as you're working through. Now Fn is F3. Fn minus 1 is F2. F2 is 2 times 2. In terms of Fn, what's really happening is this can be written as n minus 1 times n minus 1. Right? That's what it can be written as. So F2 can be written as F3 minus 1 times F3 minus 1. That's how it can be written as. Now we're asked in the problem, let's go look at what it's asking us. How many diamonds are in the figure F20? Now we've noticed a pretty clear pattern here. So what we know that we have to include 20 and 19. Those are 2 numbers that we have to include no matter what. We also have some answer choices. So we have 401, 485, 626, and 671. I think you probably understand why I'm going to rule out 401, because it's just way too small. So let's rule out 401. The other test cases, you can just test, but I'm going to find a way to compute our answer, or find it. So what we're going to do now is, we're going to turn this into an arithmetic sequence. So we're going to turn all of this geometry type stuff and turn it into arithmetic. Notice we start off with 1 diamond, we go to 5, we go to 13, we go to 25. F4 is 25. So that is 25, that is 13, that is 5, and that is obviously 1. Notice how we every time, over here we add 4, over here we add 8, and over here we add 12. This is basically an arithmetic sequence. We're adding an arithmetic sequence each time. We start off at 1, we start off at n, right? And then we go to our next number. The next count of diamonds. What's the next count of diamonds going to be? So just make it a basic arithmetic sequence based off of what we have over here. Alright. So you've come up with a solution, or not a solution, but an arithmetic sequence hopefully. Now n, we start off with 1 and we go to 5. We can say this is n plus, we can just say it's n plus 4 times 1. So we start off with f1. This is f2. Now f3 is going to be, in terms of n, what's f3 going to be? We start off with 1, and over here it's 8. It's 13. 1 plus 12 is 13. We know that. But we also know it can be written in terms of f2. Let's define f2 as k. Then this means that the next value will be n plus 4 times 1, and then we add to this, we're starting off, we add, what are we going to add here? Over here we have 5, we go to 13, we add 8, which is 4 times 2. I think you know where we're going with this. I think you probably understand where we're going with this. So this is 4 times 2. Because this is f2, we go add 8. And this will just continue, right? We just take this and we slap on 4 times 3 all the way until we reach f2. And this is going to be f3. It's a pretty complex arithmetic sequence, if you ask me. Lots and lots of numbers. So, an arithmetic sequence, what you could do is you can just keep adding multiples of 4 until you reach an answer. Since this is a multiple choice problem, I don't think it's necessarily a bad idea to keep adding until you reach one of these choices, or adding until you know you've reached the right choice, strategically adding. But for the sake of time and to gain a problem-solving skills, we're going to do this a different way, a better way. So, you might have come up with a solution here, but what are we actually doing over here? Well, over here, hopefully figure out a pattern. How are you going to get to, this is f3, and f3 has 13 diamonds. Notice how this is just 3 squared plus 2 squared. Notice the pattern yet? 3 squared plus 2 squared. Or 3 times 3 plus 2 times 2. Coming back to this over here, we notice we have a pattern. This is 9 plus 4. Alright. Now we know we're going to include 20 okay, so we have a solution. So I'm going to get the eraser out. We don't need this anymore. We know how we're going to handle the problem now. We know how that works. And I'm just going to drop the arithmetic sequence idea, because even though the diamonds are an arithmetic sequence, it's not going to help us that much. What's going to help us is that we figured out this pattern. Now, take a look at this square. This is f3. F3 has the 3s on the outside. So we know in our thing we're going to have 20 on the outside. Now to get F20, we need to add F19. We need to add all these counts all the way until we reach F1. And how are we going to do this? How do we do it here? We had 3 squared. Essentially what we did was we did Fn, we squared Fn, minus, or not minus, we added it to Fn minus 1 squared. And we got to 13. Or not 13, I'm writing this in terms of n. Let's forget about that. But we're writing it in terms of this. This is what we're actually going to do. So, we square 20. 20 minus 1 is 19. And we square 19. So that's how we're going to get to the answer. All of our work has paid off. And now I'm going to just do this. 20 squared plus 19 squared. Compute. 20 squared is 20 times 20. That's 400. 19 squared. Well, you can just multiply it, but I'm going to use a faster way. I'm going to use squares of binomials to calculate this. 20 minus 1 squared is going to be our thing. And we know how to square a binomial. 20 squared is 400. 20 multiplied by negative 1 is negative 20. Negative 20 multiplied by 2 is negative 40. Subtract off of 40. Negative 1 squared is just 1. Positive. So 400 minus 40 is 360. So we have 361. Now 400 plus 300 is 700. All we need to do is slap on the 61. And we have 761 as our desired answer. Now let's go back and see if this is true, since we have some answer choices. On the AMCs, you have answer choices, and every single AMC, from AMC 8 to 12, you're going to have answer choices. I think they even have answer choices on AMI. So over here we have 45, 55. So 671 is an answer choice, and that's E. So that is our answer. Hopefully this video is helpful, and yeah.